Once we press this button, it will save this 06 on this memory location and now come back again. And once you save it, it remains there. It will not leave that particular location until you remove it. Okay, let's now go down again to reading information. Let's now go to read. When we press this button, we now jump to read. Okay, what's the difference between save and read? They are just the same thing. The only difference there is that you will now have to tell the I2C device that you want to read information, and because you want to read information, this particular bit will now become 1, and this is the read information. A1 will now be what we have there. But first of all, we are going to send the slave address that we want to read information from. We now start by first of all calling start condition. Our start condition, then we move to accumulator 0A0, that is the slave address that we want to communicate to. We send. Then what again? We move the location we want to read information from, 00H. That is where we save our information. We call send. Okay, what again? We now have to call start condition again. This start condition will now restart the I2C, and once we restart it now, what we're now going to send now is what? Read address, which is move to accumulator 0A1. We now tell the slave address, the slave device, that we want to read information from it, not writing again, but we want to read. We send it. What again do we now do? We call receive. We call receive. This receive now will now read the information on this memory location 00H. It will now read it. When it now reads it, what then happens? Because we want to display it on LCD, once you read the information you read will now be in accumulator. So you can do whatever you want to do with that information. You can choose to do whatever thing you want to do with that information, whether display, whether compare, whatever thing you want to do with it. But on our case, we want to display that information on LCD. We now call ASCII. This ASCII is another subroutine to convert the information we read to LCD readable data. Then we now call write data. This particular line of code will now display that information on LCD. We now call stop condition. We jump main. This is the code for reading information from I2C. If you want to read, if we save from different, if we like we save on 00H. If you now want to read and now go and read on 05, you will not get anything there because your information is not on 05, it's on 00H, the first memory location. So that is where we read. Now, what again are we doing? Let's now go down to other subroutines that we have to define on this line of code. But this time around, I'm going to just do copy and paste, so it will be very fast. I'm just going to paste some information, some code I write already. Okay, let me define ASCII. This is definition of ASCII. This ASCII, when you call this ASCII, if the information you read there is 1, it will not compare. If it is 1, it will display 1 on the LCD. It will move 1 on accumulator and come back here and display it on LCD. This is because of what? Why we have this ASCII subroutine is because we are displaying the information we read from the memory on LCD. We are displaying it. If you are doing another thing with it, you will now call it, maybe you want to use it to switch on light, you can call it switch or whatever thing you want to call it. But our own, we call it ASCII because we want to display it on LCD. That is why we have this subroutine that we call ASCII. What again do we now need? Let's go to LCD declaration. That's LCD initialization that we called. Okay, this is LCD initialization. We call initialize LCD. This is code for initializing LCD. If you have not known anything about LCD, I believe I will advise you to go and read about LCD and how to initialize it. This code is for initializing LCD. Next thing again we have to do is what? A command, a subroutine for command. All this call command that we call here, we are going to define it. Look at it here. Command. We move this information to accumulator. We move this accumulator to port. Remember our port, we initialize it to be port 2. So once we move it to port, we are moving that data to port 2. So we move it to port, we clear RS, we set EN, we call delay, we clear EN. Once we do this information, that data we have on accumulator that we have moved to port will be displaying, we now display on the LCD. But on this one now, we are just, this one is for command. We are using this one to command the LCD, to tell the LCD how to behave, how to function. Okay, let me now bring the code for data writing. This is the code for data writing data. Remember, in our line of code, I called write data. So that information we read after comparing and loading it back to accumulator, we now call write data. It will now come here and move it. When we want to give command to LCD, RS, we clear it. When we now want to write data, RS, we set it, we make it high. Okay, let me just bring down some code. Then line 2, I will advise us to go and read about LCD. If you have not read about LCD, or if you don't know how to interface LCD to 8051, I will advise us to go and read about it and understand all this code that we have here. But I promise us, in our next line of code, in our next tutorial, I'm going to show us how to, I'm going to do a tutorial or a video lesson on full LCD interfacing, how to interface LCD, how to read the memory and every other thing. Okay, our test that we call, that's our test function that we call everything. Let me bring it down. All of them are still under LCD, displaying information on LCD. Okay, test 1, test 2, test 3, test 4, all this is where we define everything line by line, one after the other. Then after that, we now go to I2C sequence, both write, read and every other thing. Okay, our I2C initialization, like I told us before, initializing our I2C is just making the SDA line high, SCL high, line high. We have initialized it. Then start condition, like I explained to us before, this is our start condition. Set bit SDA, set bit SCL, clear SDA, clear SCL. You have initialized the start condition on I2C. This is our stop condition. Our acknowledge, when we want to acknowledge that the information have come. But if you don't want to use acknowledge, if you don't want to acknowledge it by yourself, the device will acknowledge by itself. When we call send, this is how we move the information to the I2C. And this is the line of code we use to read the information from I2C. The next thing we have here is our delay subroutine. So this is our complete line of code. Let me compile and see what we have. Okay, it compiled successfully. Okay, let's go back here and play it and see what we have. Okay, because you know this is that I2C lesson. Okay, loading data. Loading data. This one is delaying. Let me just go and remove this line of code so that everything will go very fast. I've removed it. Okay, let's go again. Okay. Receive that. Okay, when I press, but there is another thing I want to show us again. I'm going to use a I2C debugger so that we can be able to see how information is stored on I2C device. Let me use I2C debugger so we will see how it saves information. Okay, look at it. When we press this button now, we see how the code will be saved from the way we write our code. I press the button. Okay, look at it. This is our start condition. This is our waste. First of all, we initiate our start condition. Next thing, our slave address A0. Remember, A0, our slave address. It will acknowledge by itself. The memory location we want to write the information 00H. This is the memory location. It will acknowledge it. Next thing, this is the information we saved. 06. It will acknowledge and stop condition will be initiated. Let me show us again on our code. It will first of all do what? Start condition, that SC you see there. A0, the slave address. 00H, the memory location we want to save the information. And this is the information we save. And this is our stop condition. That P we have there. Let me play again. So we'll say it. Okay. This is the information we save. Okay, let's read that same information. Oh, I didn't. Okay, look at the information we save. Look at it. 60. It has been displaying on the screen, but there is a little mistake. I didn't add this thing. I didn't add the bounce. That's why we have that. Okay, that's true. Look at it. I didn't add the bounce. I added the bounce here. I didn't add any the bounce here. Let me copy and paste. Okay, let me assemble. Okay, let's play again and see. Okay, let me save. I've saved the information. This is the time it takes to save the information. Let me now read. Okay, I've read the information. Look at it. Start condition, the slave address. It will acknowledge the location I want to read from. It will acknowledge. I restart again. Then read address A1 for reading address. Then this is the value I read from the I2C device, and I display it on the screen. You can see it. Let me now go and read from another location that I did not save the information on. Let's say, let me read from 08. I save on 00H. Let me read from 08 and see what will happen. Okay, I have saved on 00H. I now read. Can you see it? It shows dash here. There is nothing inside that particular memory location that I'm reading from, because that is not the place I saved the information. There is nothing there. That's why we are seeing this blank page here. There is nothing on that location. This is the location I went to read from, and this is the location I saved the information from. Okay, let me now go and save on that same information that I'm reading from. That is memory 8. Let me read from it. I assembly. Okay, let me read from that location and now see what happened. Okay, I have saved on memory 8 6. Let me now read from that same memory 8. I have read it. This is the information I have there. This is the value I saved there. 6 is the value I saved there. Okay, this is the complete lesson on how to interface I2C to 8051 microcontroller using assembly language. This is the complete code on how to save and read information from I2C. Let me save another thing here. Let me save, like, let's say A. Let me save letter A. You cannot save like that, illegal operand. I have to put colon, like this, like this. Okay, let me save. I have saved the information. Okay, let me play and see what I will read. Okay, I save the value A, and remember, like I told us earlier on, there is every need for you to go and learn hexadecimal conversion. That value we saved now, we saved A, that alphabet we saved A. This is the hexadecimal value of A. 41 is the hexadecimal value of A in capital letter. When it is in small letter, the hexadecimal value of A in small letter is 31. Okay, let's read. This is the value we save. I have read it. 41. Okay, let me save small letter and see if the value will change. Small letter. Okay, let's see what happens. Okay, I have saved. Oh yeah. Okay, look at it. 61 a small letter. Then if I read, it will still display. As long as I save this information and I did not remove it by myself, it will remain there until I remove it from there. Let's say I power on again now. I will just read direct without saving. You will discover that that value will still be there. Okay, you say it will still be there. That is why we say that EEPROM is the I2C, this memory is non-volatile. You don't lose any information that you have on it. It still remains there until you erase it by yourself. So this is the lesson on how to interface I2C device to a microcontroller, 8051 microcontroller to be precise. We display our own value on LCD. You can choose to use your own value and display it, or use it to do whatever thing you want to do, or maybe use it to on and off a load, or maybe use it to compare, or whatever thing you want to do with your own. On our own tutorial, we just display the information. And remember, you can still save indirectly. Remember, I am saving data as direct now. I can choose to save indirectly. What do I mean by indirectly? The data that I want to save, I can choose to first of all move it to a memory location. Let's say 30H. This memory location is on the microcontroller side, the master side, not the slave side. Then I can choose to save the information, let's say 07 on 30H. I will now say move to accumulator 30H. Okay, I can choose to save indirectly using memory, or yes, using putting the information that I want to save first of all on memory before I save, or maybe saving direct. I now save. Look at it. I save 07. You can see it. Now when I read again, I will still read the same value that I saved. Look at it here. Okay, so you can still save indirect. Maybe at the cost of writing your code, you don't know the value that you want to save. Like here, we already know that you want to save 7, but maybe on your code you don't know the value that you want to save. Just read that value and put it on the memory register, then you save it. So whatever thing you save there will remain there. When you want to read, you still read it. But if you want to save directly, you know the data that you want to save, you can save directly. But if you don't know the data that you want to save, you can first of all move the information after your calculation, or maybe after your manipulating the code, after everything, the information you get, you move it to a memory location, then you now save. Then when you want to read, you read from that memory location that you saved it from. So this is the complete tutorial on how to interface I2C to 8051 using assembly language.